Simplifying state MPVs without being given the common denominator. So here we multiplied by 7 and by 3. And we get 35 over 21p plus 6 over 21p. Then we have a common denominator, so we can write them both over 21p. We get 35 plus 6. Now, our denominator is a monomial. If it's a monomial, it's just whatever the letter is can't equal 0. Please do not phone. So, p cannot equal 0 is going to be this one because it's 21 and it's p. 35 plus 6 is 41 over 21 and p. Can the 41 and the 21 cancel? Can they cancel? No. P can't equal 0. 41 is a prime number. All right. B has 1 over 3y and 6 over 5. 3 and y are monomial and 5 is a monomial. So you can make monomials be monomials. Both of them have a, well, do either of them have y? One of them does. One denominator has y. The other one does not, correct? So I'm going to at least have to multiply this one by y. In the top and the bottom. Now what can I make the 3 and the 5 both be? 15. So I'm going to have to multiply this one by 3y. And this one by what? What do I multiply the left-hand side of 1 by? 5. So I'm going to get 1 times 5, which is 5 in the numerator. And then we put our denominators together if they're monomials. So 3 times y times 5 is 15y. Plus 6 times 3y is 18y. Over 5 times 3y, which is 15y. Make sure you're filling in your notes if you aren't right. So then we have a common denominator, so we write them both over 15y. And our numerator is going to be 5 plus 18y. So can I cross off the y's or the 5 and the 15? Can I cancel any of that off? No. What is the numerator? That's an 18. What is the numerator? 5 plus 18y. It's a binomial. So a binomial is in brackets, correct? And a binomial can only cross off with another binomial. Is there a binomial in the denominator? There's only a monomial. Monomials can cross off monomials. There's no monomials in both, and there's no binomials in the top and the bottom. So that's as good as it gets, right? And then I just have to say y can't equal what? 0, because the denominator is a monomial. And when your denominator is a monomial, it's just that variable can't equal 0. Okay, C. We have 6x and 3x. They're both monomials. And you can make monomials be each other. So, both of them have an x already. We agree? What can we make both of them be? We have 6x and 3x. What can we make them both be? 6x. So the left-hand side is good. It already is 6x. The right-hand side, I'm going to have to multiply by 2. The whole numerator. So I get an equal sign running down the left-hand side because it's an expression, not an equation, or it would have an equal sign. I have 2x minus 5 all over 6x. And then I have minus 6x minus 4 all over 6x. Now once we have a common denominator, can we write the whole numerator over that denominator? That's the point of getting a common denominator, right? If not, why are we getting one if we're going to just use something else anyways? So we're going to get equals 6x in the denominator. And then that numerator, I have 2x minus 5 minus 6x minus a negative 4. Remember, you have to minus everything behind that. So when it's a binomial, you have to remember to minus the 4 as well. And if you don't, the answer to you forgetting that is going to be there because it's common error. So we get minus 6x minus a minus 4, so we get plus 4. So then we collect like terms. So we get 2 xylophones minus 6 xylophones is negative 4 xylophones. And then we get negative 5 of something plus 4 of something is minus 1. And then this is a binomial. And it's all over 6x. What is our denominator? A binomial or a monomial? Monomial. When we have a monomial, what is our NPV just? X can't equal 0. The top is a binomial. Is it going to go away anything on there? Does it have a twin in the denominator? No. So that's as good as it gets. All right, you guys do D. So, we have a monomial and monomial denominator, correct? We have two monomial denominators, we can make them be the same. What can we make 2a squared and 5a be the same? 10a squared. So this one I'm going to have to multiply by 5. And this one I'm going to have to multiply by 2a. So you have equal signs running down the side. So we get 5a plus 35 over 10a squared minus 6a over 10a squared. Then we have the same denominator, 10a squared. And then we have 5a plus 35 minus 6a. And then we have 5 apples. We subtract 6 apples. We have negative 1 apples plus 35. And that's a binomial, correct? So it's in brackets over 10a squared. The top is a binomial. The bottom is a monomial. Can anything cross off between a binomial and a monomial? No.
You have to write negative 1a, or can you just write negative a?
You can just write negative a. And you don't actually need to show the brackets in the top. I just put the brackets to prove a point that you can't cancel them off. Because what other people do is they'll cross off the 35 and the 10, which you can't do. Okay? And then you have a can't equal what? 0. So technically you could have negative a plus 35 over 10a squared just like that. A can't equal 0, right? The same thing. All right, then we're going to flip over. Sorry. Had everyone have that? Okay, what is the catch on E? One's a binomial, one's a monomial. The one, when it's one is a monomial and one is a binomial, they're the easiest ones to do. Because you can't make a monomial be a binomial, and you can't make a binomial be a monomial, so you just multiply them by each other. So there's no thought process. So this one has 2x, it's a monomial. The other one is x minus 4, it's a binomial. You can't make them be each other, so you have to multiply them by each other. So I'm just going to rewrite it out so that it's bigger. X minus 9 over 2x plus 3x over x minus 4. So this one is a binomial, correct? So I'm going to multiply this one by it. And then this one, I'm going to multiply by the monomial, so 2x. Now guys, is it helpful to put the denominators together? Do I have to, if I put those denominators together, does it make it more simple or more complex? If I put the denominators together, it would make it more complex, wouldn't it? Does it make the denominators any better or any more common if you put them together? When it's a binomial and a monomial? No. And if you put them together, you're just going to have to GCF it back out, right? So we aren't going to put our denominators together ever when it's adding and subtracting or solving. We'll just leave them apart if it's a monomial and a binomial. The only time you put them together is if they're both monomials. So I have to FOIL this one. First times first, because it's binomial times a binomial. So x times x is x squared. X times negative 4 is negative 4x. Negative 9 times x is negative 9x. Negative 9 times negative 4 is positive 36. All over 2x times x minus 4. plus. Then we have 3x times 2x is 6x squared. Remember when you multiply, you actually add exponents of the x's, so that's how you get an x squared. You're not putting together like terms like before. All over 2x times x minus 4. Now they have a common denominator, so I can write them all over it. 2x, x minus 4. And then I get x squared minus 4x minus 9x plus 36 plus 6x squared. I can write them all over one denominator because I have a common denominator, correct? Then I collect like terms. So I get x squared plus 6x squared is 7x squared. Some people are like, why does it become x4? You are not multiplying. You're just adding and subtracting. Adding and subtracting, you can only put together like terms. So things with the same x's. And then I have negative 4 xylophones minus 9 xylophones is negative 13 xylophones. And then plus 36. And then it's all over 2x, x minus 4. Does my denominator have a monomial? Is that a monomial? One term doesn't have a plus or minus sign. So x can't equal what? 0. When your denominator has a monomial, you immediately have a non-permissible value of 0. Now this one I have to do a little more work. It's x minus 4. What would cause that bracket to be a 0? If x was what? 4, right? 4 minus 4 is 0. Do we agree? Yes? So can x equal 4? If this is 4 minus 4, it becomes 0. 0 times 2x is 0, correct? So we're trying to find out all the x's that would create this to be 0. So if I put a 4 in here, 4 minus 4 is 0. So x also can't equal 4. I want you to grab out a separate sheet of paper, yeah?
Why don't you multiply the ones on the bottom?
Because if you multiply them, you're going to have to take them back out. Because it says simplify. So if you put them back in, you're going to have to GCF a 2x back out. So you could do it, but you'll just get back to where you first did. So with adding, subtracting, and solving, we don't put together the denominators. Bad case, you do. Who cares? Take it back out at the end. Okay? Okay, separate sheet of paper. I'm going to have you try to do these. Simplify. It's because you don't have trinomial factor. Yeah. Okay, try these out. Okay. So, this one here has 3x to monomial. The other one has a binomial. So when you have a monomial denominator and a binomial denominator and you're adding and subtracting, you multiply by the other one. So x plus 3 is what I'm going to multiply this one by. And I don't put my denominators together. And then this one I'm going to multiply by 3x. So I get x squared plus 3x minus 4x minus 12 all over 3x, x plus 3 minus 12x squared all over 3x, x plus 3. So you don't put them together if they're a monomial and a binomial. And why? Because if you put them back together, you're going to have to GCF the 3x back up at the end. So we don't put our denominators together. And we already have a common denominator, so there's no point in putting them together. So we have 3x, x plus 3. And in the numerator, we have x squared plus 3x minus 4x minus 12 minus 12x squared So in the bottom, we still have 3x in the denominator, x plus 3. In the numerator, we collect like terms, so we get x squared minus 12x squared is negative 11x squared. And here we have 3 xylophones minus 4 xylophones is negative 1 xylophone, and then minus 12. X can't equal what? 0 because of the monomial. And then negative 3 because negative 3 plus 3 is 0. Now this one we have a 2x, a monomial, and a binomial, which is x plus 3. You agree? So I have to multiply them by each other when it's a monomial, binomial. So this one I'm going to multiply by x plus 3. And this one I'm going to multiply by 2x. So in the numerator, I'm going to get 2x times x, which is 2x squared. 2x times 3, which is 6x. 1 times x, which is 1x. And then 1 times 3, which is 3 plus 3. All over 2x, x plus 3, plus x times 2x is 2x squared. And then negative 4 times 2x is negative 8x. And then we have 2x, x plus 3. Same denominator, so we can write them all over it and not distribute it because we'd have GCF to back out if we do. In the numerator, we get 2x squared plus 6x plus 1x plus 3 plus 2x squared minus 8x. And so I get 2x, x plus 3 in the denominator. And then I get 2x squared plus 2x squared is 4x squared. 6x plus 1x minus 8x is negative x. Minus 1x, sorry. And then plus 3. And then we say x can't equal what? 0 because of the 2x, it's a monomial, and?
Negative 3.
Negative 3, because negative 3 plus 3 is 0. All right, so what we've done so far is if we have monomial denominators, we can make them both be monomials. We agree? If I have a monomial and a binomial, I can't make them be each other, so I just have to multiply by each other. Now, this one is a what denominator, what denominator? What is F? What kind of denominators?
Binomials.
They're both binomials. They're both binomials. So unless they're twins, you can't make a match, or unless you take out GCF for difference of squares. So look here. I have a 2y plus 5 and a y minus 3. Is there any way I can make them be each other? No. So what am I going to have to multiply them by? Each other. Literally. I don't know what you said, but okay. So we get 4 over 2y plus 5. Then I'm going to have to multiply this one by y minus 3. And then I get a minus sign, 1 over y minus 3. And I have to multiply this one by 2y plus 5. Now guys, if we put the denominators together, we're going to have to pull them back apart by decomposition. So this is one where you're not going to want to put them together and then pull them back apart. Okay? So we don't want to put those denominators together when it's a binomial and a binomial, or else we're going to have to decomp to pull them back apart. But we do distribute our numerators. We distribute our numerators, but not our denominators. So we get 4y minus 12 over 2y plus 5, y minus 3, minus 1 times 2y plus 5, so minus 2y plus 5, all over 2y plus 5, y minus 3. Do my denominators match, guys? Do my denominators match? When my denominators match, I can write it over one denominator. We agree? So I'm going to get 2y plus 5, y minus 3. And in the numerator, I get 4y minus 12. What do I have to remember with the subtraction, guys? Because if you don't, you're going to make this mistake every time. What do I have to remember with that subtraction? It subtracts everything. We agree? Does it subtract both the 2y plus 5, or does it just subtract the 2y? You said yes. There we go. Cool. I was like, yes, it doesn't work in this instance. Okay. Cool. So we subtract the 2y, and we have to subtract the 5. If you forget, the answer to you forgetting will be there. So don't forget. So the denominator, I have 2y plus 5 and y minus 3. And in the numerator, I have 4 yaks minus 2 yaks is 2 yaks. And then I have negative 12 something minus 5 more something. I get negative 17. That is a binomial. Is there a 2y minus 17 in the denominator? Is there a 2y plus 5 in the numerator? Is there a y minus 3 in the numerator? No. So is any of that canceling off? Because binomials have to be twins to cancel. There's no twins here, right? Now, how do I get my NPVs? Some people get stuck on the NPVs. So I see this one, the y minus 3, and I say, okay, well, make that bracket a 0. Y can't equal 3. That one's easy. The 2y plus 5 confuses people. So what you can do is you can go y minus 3 can't equal 0, and move your 3 over and say y can't equal 3, right? You can totally do that. So we can do the same with 2y plus 5. 2y plus 5 can't equal 0. 2y can't equal negative 5. And then y can't equal negative 5 halves. So that's my other NPV. And there we go. Yeah? Okay, this one I have an x minus 5 and an x plus 1. Can I make them be the same? No, so what am I going to do? Multiply them by each other. I'm going to multiply the left-hand side by x plus 1 and the right-hand side by x minus 5, right? Let's try it out. So, we have 2x plus 1 and x minus 5. And then, we're going to multiply by x plus 1 in the numerator and the denominator, make a common denominator, just like you would like a 2 or a 3 back in junior high. Make sure your phones are away. Then, we have minus x minus 4 over x plus 1. And now we're going to multiply this one by x minus 5 and x minus 5. And so we get 2x squared plus 2x plus 1x plus 1. Do I expand my denominator? Do I put together my denominator?
Yeah.
Yeah? And then I give him the look like that. He's like, no, no. We don't put the denominator together because if we put it together, we're going to have to do product sum to get it back apart. So we get x minus 5, x plus 1. And along our left-hand side, we should have equal signs running down it, right? Make sure you have those. Then we have minus x minus 5x plus 1 on this one again. And we expand the top only. So x times x is x squared. X times negative 5 is negative 5x. Negative 4 times x is negative 4x. Negative 4 times 5 is positive 20. And then I get all over one denominator. That's why we made it common. X minus 5x plus 1. So I have 2x squared plus 2x plus 1x plus 1. What do we have to remember to do with all the terms after the minus sign?
Flip their signs.
Flip their signs, because you're going to minus them all. You're minusing this, you're minusing this, minusing this, minusing this, or multiply by negative 1. You could look at it that way. So it's going to be negative x squared plus 5x plus 4x minus 20. And so it equals 2x squared minus x squared is x squared. 2x plus 5 plus 4 is plus 12x. And then plus 1 minus 20 is negative 19. We do not have to factor. X can't equal what, guys? What can't x be? Positive 5, because that would make this be 0 and? Negative 1. All right. Last one, you're trying on a separate sheet.